Hi, my name is Steve Hedden. I'm a product manager at Top Quadrant, and today we're going to talk about GraphRag and how to build a GraphRag app. If you don't know Top Quadrant, we are a software company. Our primary product is Top Braid Edge, and we specialize in helping large enterprise companies, primarily in life sciences and financial services industries, build knowledge graphs. And Top Rate Edge is a knowledge graph tool, help you build your knowledge graph and update it over time. And so we'll be using that today along with some other technologies to build a GraphRag app. Here's what we're going to talk about today. What is GraphRag? Just get clarity on exactly what we're talking about. What do we mean by this? And also how knowledge graphs and large language models work well together. Now, GraphRag is one example of how they can work well together, but there are many other ways they could work well together. Then we'll just go through step by step how we built this thing by preparing the data, searching, refining the terms, and then filtering to send to the LLM. I'll talk through all of that, and then we'll go into the actual app, the demo of what we're talking about. So first of all, what is GraphRag? Well, it's RAG with a graph. So what is RAG? RAG is retrieval augmented generation. What it means is instead of sending your prompt directly to an LLM, so in this case, and this is the example you will use throughout this presentation and the demo, instead of sending what are the different treatments for mouth cancer directly to the large language model, say it's ChatGPT, you can ask ChatGPT that question directly and get probably a pretty good response. You can also supplement or augment your prompt with additional relevant context. And so in this example, say you have a ton of journal articles, find ones that are about mouth cancer, give that to the LLM along with your prompt, and you should get better results. This is appealing for a lot of companies, mostly because LLMs were trained on a ton of data, but they weren't trained probably on your internal enterprise data. And so you can get better results if you give it relevant content. And I said probably and theoretically, because as we'll see in this demo, it can backfire. If you give the LLM a lot of irrelevant context, it might give worse results than if you just give it nothing. And that we call context poisoning. And so I'll show that today. We'll talk about it at least. And we'll keep with this same example throughout. One step back, high level, there are pros and cons to both large language models and knowledge graphs. But as this diagram shows, they often cancel each other out, or at least counteract each other to some extent. And it's a primary reason why so many people are excited about combining these two technologies. And I'm not going to go through this all. There's a link there to where this came from in this journal article, but I just want to highlight that GraphRag is one way these two technologies work well together, but there's a lot of others. They're listed in that article. And from a conceptual basis, some of the biggest downsides to using large language models are that they are black box models. You have no idea, there's no explainability in the results you get, and they can hallucinate or give false and misleading information. Knowledge graphs are very much not black boxes. They're completely understandable, interpretable, transparent collections of facts, but they can't, answer human language questions the same way a large language model can. They don't hallucinate because they're facts, but you can't chat with them. And so the idea is like if we can combine these two things, that usability and chat interface, but also with structured facts, we can have the best of both worlds. GraphRag, which we'll talk about, is one example. So step one to building a GraphRag app is preparing your data. For this demo, I've used a data set of journal articles from PubMed. So this is medical journal articles. And it's actually not all the article, it's just the abstract and a bunch of metadata. But that's the underlying raw data. Also, each of those articles is tagged with terms from MESH, which is the Medical Subject Headings Thesaurus. That's a large controlled vocabulary, and the terms come from there. So we'll see why that's important. But that's the raw data. So step one to to prepare it, we need to do two things. One, take all those journal articles and their metadata and vectorize them and store them in a vector database. So I've used Weaviate here. You can use whatever vector database you want, but that allows for vector-based retrieval. So given a prompt, find the most similar results. You could also do that with the terms themselves, which we'll see. So those mesh terms. So I want to search for mouth cancer, but it actually gives me mouth neoplasms. That works with a vector similarity. The other thing we need to do is prepare the knowledge graph or an RDF database to query and filter the results. I've used Top Rate Edge, of course, for this, and that's the same data, just stored in RDF format. Once it's in those two formats, step two, you can actually search, the initial search, so this initial retrieval. So send that prompt, treatments for mouth cancer, to the vector database, find the most similar journal articles from that database to my prompt. And you can see this is an example of some of the results you get. So it might be, say, something about treatments for mouth neoplasms, therapies for esophageal neoplasms, or treatments for rectal cancer. Those were determined by the vector database to be the most similar to the prompt. Maybe you want to include those in your prompt or add them as context to your prompt when you send it to the LLM, or maybe you don't. That's what we'll play with a little bit, but that's what's returned, or examples. But say you don't, say I don't want rectal cancer treatments going into my description of treatments for mouth cancer. Fair enough, let's get rid of them. How? Well, those mesh terms are tagged with different medical terminologies. And so you could use those to filter results. And you can say, well, I only want of those results that you returned ones that are explicitly tagged with something like mouth cancer. This is why we vectorize the terms, because you can say mouth cancer and it will say, did you mean mouth neoplasms? Yeah, it's the same thing. Okay, that's what the term mesh uses. That's great. But mesh is also a very rich control vocabulary, which means it has alternative names or like synonyms, and also narrower and broader relationships. There's a ton of relationships, but it includes those. So that's relevant for us because you can say, well, I want to include mouth if it's tagged with mouth neoplasms, but also if it's tagged with anything that's a subset of that. So maybe it was tagged with, tongue cancer. That is a subset of mouth cancer, so that it counts. We want to include that. That's why that filter layer and the ability to have as part of a richer control vocabulary is so important. Now you have a refined list of articles that are only the ones you actually want. You can send that with your original prompt, what are the different treatment options for mouth cancer, to the LLM. That's the filter and summarize results. So that's how it works in theory. Let's get into how it works in practice by looking at an actual app. Okay, so this is the app. We can go in and go through the same steps that I just described, but now in real life, in this real app. The step one we just talked about was preparing the data. The data has already been prepared. We've created a knowledge graph in RDF format that we'll use for the filtering. And we've sent all of those PubMed journal articles to the vector database so we can do vector-based retrieval. For the vector-based retrieval, if you're unfamiliar with vector databases, what they are and why they're important, the shortest, simplest version is that they take strings and turn them into vectors, which is just a long list of numbers, so that you can find similar results, or you do search on a prompt and find similar entities within that vector space. It uses an underlying LLM to turn them into vectors. And so it has like the knowledge of all of the content that the LLM was trained on. So it's not an LLM in that it can't generate new responses. It's not generative. You can't chat with it, but it has the same training data to do those searches and similarities. And so they call it semantic search and semantic similarity, which has a different meaning in the knowledge graph world. And so I'll just call it vector-based retrieval And that is generally, as far as I've seen, how a lot of RAG applications are built. That first step is vector-based retrieval. And so what it does, it's just search and similarity using AI to find the most similar results. Since I've vectorized all of our journal articles, given any prompt here, it'll return the most similar results so that we can use them. So let's search for mouth cancer and find all of the journal articles that are most similar. I limited it to 10 for the purposes of this demo. And so let's go through them. I'm going to search just to make sure. So here you can see the title, abstract, distance. So again, this is distance in vector space. It's not really relevant just to say that these, order of increasing, which is closest. So this top one is the closest. Why? Well, it is tagged with gingival neoplasms, interestingly. And this is what we're going to go through a few of these. I just want to show why this is important, where it's really powerful and good, and why there are some problems with it. So gingival neoplasms is cancer of the gums. The gums are part of the mouth. That's relevant. That's important. It's similar. It does not say mouth cancer in it. It doesn't say mouth neoplasms in it, actually. It doesn't say anything. And I've searched for mouth cancer and it returned this. So that's the power of a vector database. It understands, well, gums, gingival, that's close to the mouth, that's probably relevant. Put that top. But it's also tagged with pleural neoplasms. That's cancer of the lungs, less relevant. Next one is tagged with mouth neoplasms. And actually, I searched for mouth cancer on purpose because Mesh does not use the term mouth cancer, it uses mouth neoplasms. The vector space, the vector database is smart enough, it knows that that's similar. Again, this one is tagged with mouth neoplasms, esophageal neoplasms. Interesting. While the gums are part of the mouth, the esophagus is not, but it's close to the mouth. And so this is a place where the vector space said this is similar to your search term, but only I know if it's relevant. And if I am searching for only articles that are tagged with mouth cancer or narrower concepts, this would not be included. And that's super important because, the vector database is doing pretty smart to know that, well, it's esophagus, maybe he's interested in that, but it's up to me as an expert. I'm not an expert, I'm not a doctor, but if I were using this as a tool, it would be up to me to do that. I'm not, so I'm going to use the mesh control vocabulary, and we'll talk about why that's so important. This next one, interesting, facial neoplasms, not part of the mouth, broader than the mouth, probably not relevant. Rectal neoplasms, again, I'm not a doctor, but I'm pretty sure the rectum's not part of the mouth. That is probably not relevant for this search. But again, see, it's included, I would guess, because it says facial neoplasms, mouth is part of the face. Mandibular, same thing. Mandibular means jaw. Jaw is kind of mouth. Technically, it's not part of the mouth. And so this is just a great example of articles that are returned because of vector-based retrieval, some of which are super similar and super relevant and helpful, and some are not. And it's only by using human curated knowledge, in this case, this mesh control vocabulary, that I can determine what's relevant and what's not. So we'll go through that. This last one I'll highlight here is just palatal, which is palate, top of the mouth. That is a subset of mouth cancer. So we probably do want to include that. How do I know, though? If I don't know this, that's why the second step is so important. Because if I just did this query and sent all of these results directly to the LLM, that could lead to context poisoning, because I gave it a few things about mouth cancer and a few things about rectal cancer. And I said, summarize these results and tell me how to treat mouth cancer. And it might do something very misleading. It might say, here's how you treat it. It might be telling me how to treat rectal cancer when I'm actually asking about mouth cancer. So how do I know? This is why this mesh control vocabulary is so important. Now I search here. I've used vector-based retrieval on the mesh term so that I could search mouth cancer and get mouth neoplasms, because suppose I don't know that. Suppose I don't know that the appropriate term is mouth neoplasms. I can select that. So now it's one of my search terms or one of my filtering terms, but I can also expand it and get narrower concepts, and an alternative name. So I'm going to include cancer of mouth, which actually isn't used, but they list it here as an alternative name. And then all these narrower concepts. There are actually multiple layers that I'm not going to get into. Like there's subsets of palatal neoplasm and subsets of all these other ones that I can't even pronounce. But I will only select the first layer, and you can see they're all added here. I'm going to use these terms to filter those initial results. So now I have this list of terms. I have those 10 original articles. I'm going to filter them. So I'm only including those 10 articles, ones that are tagged with one of these terms. Okay, so here are the articles returned. You can see that instead of the original 10, now we only have 4, but each of them is tagged with either mouth neoplasms or palatal neoplasms or gingival neoplasms, because as the mesh control vocabulary told us, those are subsets or narrower concepts of mouth cancer. We know that these are all about mouth cancer if our tagging was done correctly. Now we can send these to our LLM along with a prompt and in theory get much better results. If we had not added this filter layer, then we would have sent both relevant and potentially irrelevant context to the LLM and asked it to summarize the results. Could have been very misleading. Now we're a lot more sure that we're giving it relevant context. So I have a default prompt here, summarize the key information here in bullet points, make it understandable to someone without a medical degree. I'm just going to add in here, focus on treatments for mouth cancer, because I don't have this automated. I didn't, I'm not telling it treatments for mouth cancer. I'm just from before, right? You can automate this or imagine how this could be automated where the original prompt from step 1 is carried into here, but I haven't done that. This is a totally new prompt I'm generating or I'm creating to send to the LLM along with this context. And then I'm just going to press this button, summarize with LLM. Let's see what it says. So key information on treatments for mouth cancer. So it heard me say I only want treatments for mouth cancer, and it's using the context provided here. So most of this is just summarizing these abstracts from these. And so actually, let's just talk, I'll show you. This first one is feasibility study of screening for malignant lesions in the oral cavity targeting tobacco users. And so these facts here are just about that. This pilot study and these and findings of the screening. So this is all just summarizing that first article. And then the next one, or this one, is about mesothelioma. And you can see that that's summarized here as well. Local radiotherapy, chemotherapy. These are things that are talked about in this article. So you can see. So this article is about that gingival neoplasms, and treatments are chemotherapy and radiotherapy. So essentially, this is just summarizing those articles, putting into bullet format. It's not doing anything, that outrageous. I haven't gone through line by line, of course, to check to make sure there's no hallucinations. There's still the possibility of that, right? This is still using an LLM to generate a response. There's possible it could summarize it incorrectly, that it could be wrong, it could be giving completely false or misleading information. The likelihood of that has decreased by filtering out some of those other articles, but that is still a possibility. There's no way to get around hallucinations entirely. And so those are results. I think that this last step is kind of not as exciting because we're really just summarizing things. And if you use ChatGPT at all, this shouldn't look that different. If you gave it and just copied and pasted those 4 abstracts into ChatGPT and gave it that prompt, it would give you this exact result. There's nothing fancy going on here. So let's go back to slides and just talk about major takeaways. One, this is not domain specific. I think that's probably pretty clear, but this works for other domains other than life sciences, other topics other than mouth cancer. This is just a demo. This is very applicable in many domains that we're seeing in the field, and this is also not just specific to this exact sort of use case. This use case or this kind of app you could imagine being helpful for a researcher, but if you tweak it a little bit, you can imagine how it could be used for automated report generation. So in that last prompt that I sent to the LLM, if instead of saying summarize these results, I were to say use this context to answer this question, and the question or the question were something that a regulatory body were asking me, you can imagine how you could build a pipeline to do this to automatically generate reports or to respond to regulators or anything like that. And so those are use cases that are being implemented right now. Probably talked about this enough already, but the real magic is in the controlled vocabulary. That's probably an exaggeration. There's magic in AI too, but the whole point of this demo is just to show if you just do vector-based retrieval and send that directly to an LLM, you can get very bad results. If you use some sort of professionally curated knowledge base, you can ensure that your results are a lot more accurate. Finally, speaking of accuracy, this is not just about accuracy. I mean, this demo really is. It's really all we've talked about in a lot of the GraphRag demos that I've seen and heard people talk about. It's really about accuracy. It's missing a big piece because it is true that by including graphs in your RAG pipeline, you can improve the accuracy, reduce the likelihood of context poisoning. There's a lot of benefits. But it's also missing another key component, which is that filtering step that I showed. We just filtered out things that we found to be or we thought to be irrelevant based off the original prompt. You could also filter out context that is the user or the app does not have access to. So you could use it as an access control layer or a governance layer, and that could be based off, again, the app, or it could be based off the person. If you had metadata about who's asking this question, maybe they weren't allowed to see that. And so for this example, like all toy demos, we're using, a well-curated data set of PubMed journal articles. Suppose this is sitting on top of your SharePoint and there's a lot of HR payroll data in there. You want to make sure that that never gets, used as an additional context whenever someone asks a question to your chatbot or whatever you're making. And then related to that, but a little different, is efficiency and scalability. And what I mean here is just that it's pretty easy to get a GraphRag application up and running. I just showed how to do it. I'll show the code, and you can get it up and running very easily, very quickly. But what we don't want, what's not as good as to get a one-off application that's just useless in a year, and that's very likely, and we're seeing a lot of that. And the way to get around that is to ensure that you're using sort of a metadata layer as a platform to build AI on top of. So what that means is, keeping this the same example, suppose I built two different applications, one for both, say they're about drug discovery or research on journal articles like this, but one is for customers or patients and one is for employees. You want to use the knowledge graph to do governance in terms of dictating which data should go to which application, maybe some additional access control, business rules, but also connected to that third-party mesh control vocabulary, so that if something were to change, whether in your knowledge graph because of governance rules or in that mesh, then you could change it there and the applications would inherit those changes downstream instead of having siloed applications. And when you say, oh, the mandible is actually now part of the mouth, you have to go into every application and change it. That's probably a bad example, but maybe an access control rule changes. That's more likely, and you could change that at one place as downstream effects. That's a huge benefit that is not talked about nearly as much as accuracy. So that's it. I'll end it here. If you want to see the code for this demo, it's on my GitHub. If you want to see the tutorial for exactly how to build this step by step, that's on my Medium post. And then you can reach out to me directly, Hedden at topquadrant.com. Thank you very much, and have a great rest of your day.